In this DB4IoT Mobility Analytics Platform use case video, we'll demonstrate how to create Freeway on-ramp to off-ramp origin-destination matrices. In this example, we've loaded INRIX trips data for the Vancouver, Washington area. Each dot on the map represents a waypoint for a vehicle reporting its location, speed, and direction at a certain point in time. We can visualize this data as waypoints or as road segments. Let's get started by defining some freeway entrance filters, on-ramps, for I-5 southbound traffic. We select an on-ramp by clicking it on the map. And then add this road segment as a filter to the selections in the side panel. And repeat this process for each relevant on-ramp. Now that we've defined and saved the freeway entrance filters, on-ramps, we'll do the same for the freeway exit filters, off-ramps. This is simply a matter of repeating the same sequence of actions we used to create the entrance filters, but in this case, saving them as exit filters or off-ramps. Now we can view our filters on the map, the entrance filters, on-ramps, and the exit filters, off-ramps. Next, we'll build out the network of on-ramps and off-ramps, positioning I-5 southbound in the center, the on-ramps on the left, and the off-ramps on the right. We connect these various nodes to create the network configuration. Now that we've defined the entire network configuration, we can begin using it in our analysis. When we load the network, we have a series of new columns to make selections in the side panel. We can view the distribution of trips that used the on-ramps and off-ramps defined in the network. Next, we'll generate a table of OD information. In this case, we'll select trip counts and raw speed, and group by on-ramps to off-ramps. We can sort this by the highest frequency of either, and export this information as a CSV file for use in Excel or other offline tools. We can further refine our selections to analyze, for example, morning peak travel. We'll select Tuesdays through Thursdays and 5:30 through 9 a.m. in 15-minute increments. The data is updated in the side panel to reflect only trips that took place during those days of the week and times of day. And, as previously, we can generate an OD table and CSV export of this information. We can also view an OD matrix chart. In this example, choosing the I-5 southbound off-ramps as the x-axis, I-5 southbound on-ramps as the y-axis, and coloring by unique trip count. And we can download this information as a spreadsheet. Instead of looking at an OD matrix from on-ramps to off-ramps, it can also be interesting to analyze traffic that is avoiding the freeway, for example, during the morning peak. To do this, we can define a new filter network that looks at traffic going from off-ramp to on-ramp. In other words, leaving the freeway because of congestion, traveling on surface roads, then later re-entering the freeway. What you see here is the exits on the left and the entrances on the right. And we've defined links from every exit to every downstream entrance so that we can generate OD matrices for traffic from exit to entrance on I-5 southbound. And finally, we create the table to display which exit to entrance pairs generate the highest trip counts. We can drill down even further to view waypoints. The side panel shows the distribution of trips defined in our avoidance filter. We'll select the 176 exit to view which on-ramps those trips are taking to re-enter the freeway, and then select a specific downstream entrance, the 131 on-ramp. Next, we'll zoom in to downtown Vancouver to see which surface streets and routes were used as a bypass to avoid freeway congestion between that specific exit, number 176, and the downstream freeway on-ramp entrance, number 131. Thanks for watching this DB4IoT Mobility Analytics Platform by Moonshadow use case video. For more information, contact us or visit our websites.